Hi, my name is Luis, and my project is about cannabis sativas and their similarities to other plants. Here's the overview to know which of what I've used for. Cannabis sativa L is a plant known for its psychoactive and medical uses because it contains compounds like THC, which affects the human brain. It is often controlled by the law. However, some other plants look very similar to Cannabis sativa, making it hard for scientists and police to tell them apart. Traditional methods for identifying cannabis, such as chemical text or looking at other features under a microscope, takes a long time and sometimes gives unclear results. New technologies such as ATA-FTIR, which allows samples to be examined directly in the solid or liquid form without preparation, and PLSDA, which is used to pattern recognition. It can help solve this problem. These tools allow scientists to study the chemical makeup of plants quickly and accurately. Using these tools can help identify cannabis in a faster, reliable, and more environmentally friendly way. Even with better technology, identifying cannabis is still challenging. Some plants, like Humulus lapillus, commonly known as hops, and wild hemps, have chemical and physical traits that are very similar to cannabis. Because of this, tests can sometimes give false results, showing that a sample is a cannabis when it's not. This can lead to problems in legal situations where accurate results are very important. Many of the older tests, like chromatography or visual identification, can also be costly or require a lot of time. Forensic science are now looking for faster, easier, and more consistent ways to identify cannabis correctly and avoid mistakes. The main goal of this research is to find if combining ATR-FTIR and PLSDA can correctly identify cannabis and telling it apart from other plants that only look similar. The researchers believe that by using solvent extraction with those advanced testing methods, they can get clear and accurate results. This method could become a dependable way for forensic labs to test plant samples and help reduce confusion in future drug investigations. The article explains a method that can help scientists tell cannabis apart from other plants that look very similar. The method works by studying the chemical makeup of each plant. Every plant has its own chemical fingerprint, and this fingerprint can be measured by using a tool called ATR-FTIR. ATA-FTIR shines and flared light on a sample and records how the chemical absorbs the light. This absorption pattern creates a spectrum, a kind of graph that shows what the plant is made of. Cannabis sativa has certain chemicals such as cannabinoids and terpenes that show up clearly in these spectra. Other plants do not have the exact same chemical patterns. Because of this, the spectra can be compared to see which samples are cannabis and which are not. After the spectra are collected, a computer method called PLSDA is used. PLSDA looks at all the data and separates the samples into groups based on their chemical patterns. This helps researchers identify cannabis when the plant looks almost identical. Samples of cannabis and similar plants were prepared using the same steps to ensure consistency. First, each plant sample was dried and ground into powder so that all materials had a uniform texture. A solvent extraction was then performed to isolate the plant's chemical compounds. In this step, the powdered sample was mixed with an organic solvent commonly used in chemical analysis. The solvent penetrates the plant tissue and dissolves key compounds such as cannabinoids, terpenes, and other metabolites, pulling them out of the solid plant fiber into the liquid phase. Once the chemical had fully transferred into the solvent, the liquid extract was separated from the remaining plant solids. This extract provided a cleaner and more concentrated chemical sample for ATR-FTIR testing. After extraction, a portion of each liquid sample was placed on the ATR-FTIR instrument. ATR-FTIR spectra were collected using identical settings for every sample, including the same scanning range across the mid-infrared region so that the major plant chemical signals were captured. The same resolution to keep the peaks equal, sharp, and detailed, the same number of scans to ensure constant signal quality. Keeping these settings help ensure accurate and comparable results. The spectra represented the chemical fingerprint on each plant. The ATR-FTIR spectrometer was used to collect infrared samples from 490 total samples. The instrument was set to 80 Celsius and spectra were recorded from 4,000 to 650 centimeters, -1. Before each reading, a black was taken so that the crystal's background signals. The samples were prepared for 3 different solvents: chloroform, ethanol, and petroleum ether. When the raw spectra was compared, cannabis showed stronger and clear absorbance than the non-cannabis plants. These differences appear across the whole spectral range, were especially noticed in the mid-infrared region when major chemical groups absorb. Among the 3 solvents, ethanol produced the cleanest and most consistent spectra with sharper peaks and the less variations between samples. Chloroform and petroleum ether extracts also separates the groups, but not as clearly. PLSDA was then used to see if spectral differences were strong enough for classification. The ethanol-based PLSDA model gave the best results and showed a clear separation between cannabis sativa and the non-cannabis plants. The chloroform and petroleum ether models also separate the group, but not as clearly, which suggests that ethanol interacts better with the compounds that help identify cannabis. These findings support previous work by, I don't know how to pronounce his name, but in 2025, who also found that solvent extraction ATR, FTIR spectra combined with PLSDA can reliably distinguish cannabis sativa from visual similar species. And there's another one, which I don't know how to pronounce his name, also was in 2022, had a similar report that chemometric modeling strengthening the separation between cannabis chromatography when FTIR ATR data was used. The results of this study show that combining ATR FTIR spectroscopy with PLSDA chemometric modeling is an effective way to tell cannabis sativa apart from plants that look similar. Cannabis samples consistently displayed stronger and more recognizable chemical fracture, which made separation easier. One major finding was that ethanol extraction gave the best results. The spectra obtained using ethanol were cleaner, more constant, produced the cleanest separation in the chemometric model. Ethanol is also considered a green solvent, meaning it is safer for the environment and less toxic to use in a lab setting. This makes it a practical choice for both routine testing and teaching labs. Also, the findings support the idea that ATR-FTRI fast, sample, and reliable screening tool. When combining the PLSDA, it can help scientists in forensics analysis quickly check whether a plant sample is cannabis without needing more complicated or expensive testing methods. However, there are several limitations to consider. Controlling lab conditions. All samples are prepared and tested in a controlled lab environment. Real-world samples may be exposed to weather, soil differences, and contamination, which could affect the chemical profile. And these are the ones that I used on my references. And these are my references. Thank you.